Welcome to Customer Churn Analysis. Customer Churn Analysis. What is customer churn analysis? Why is it important for businesses? Our lesson will use a real-world telecom churn dataset. We will analyze patterns and visualize insights. No prior experience is needed. We will learn step by step. Let us get started. Running the cell now. Let us understand what churn means. What is churn? Churn means a customer has stopped using a service. Churn rate is the percent of users who leave within a period. High churn can signal customer dissatisfaction or competition. Reducing churn boosts company profits and growth. Churn analysis helps us find what drives customers away. Running the cell now. Why should companies care about analyzing churn? Why analyze churn? Keeping a customer costs less than finding a new one. Understanding churn reveals where service can improve. Data mining finds patterns in customer behavior. Insights from data can help reduce churn and save money. Many industries track churn: telecom, banking, SaaS, and more. Running the cell now. Now, let us move to our data. Let us start by turning off warnings for a beginner-friendly experience. We suppress warnings so nothing distracts us in the notebook. Import warnings, warnings.filter warnings, ignore. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This initial code sets up a clean and consistent environment by suppressing warnings and fixing the random seed for reproducibility. While it produces no visible output, these steps are crucial to ensure that subsequent data analysis and modeling, such as studying customer churn patterns, are clear, reliable, and comparable across runs. Now we are ready for the data. We will load our telco customer churn dataset using pandas. This data records telecom customers and whether they left the service. Hash data setup. We import pandas, a powerful library for data tables. We use the URL to fetch the telco churn dataset. We read the CSV data into a data frame called df. We print the shape to see how many rows and columns we have. We print the first 3 rows to preview the data. Running the cell now. The output shows the dataset has 7,043 customer records and 21 columns, giving a broad view of customer demographics, services, and billing details. Notice key columns like churn, tenure, and payment method, which are crucial for analyzing customer behavior and identifying patterns linked to churn. This initial data inspection sets the foundation for understanding what factors influence churn and how the dataset can be mined to find actionable insights. You should see some basic customer details like tenure, contract type, and whether they churned. If you are enjoying this lesson, subscribe to the channel for more beginner data science videos. Let us check what columns or variables exist in our data. Take a closer look at columns. We print the list of columns so we can understand what information is provided. Running the cell now. This output lists all the columns in the customer dataset, showing the available features for analysis. Notably, it includes customer demographics, service usage, billing details, and the key target variable churn. Identifying these columns helps us understand what customer attributes might influence churn, guiding our exploration and modeling efforts. Each column is a feature. Features help us analyze and predict churn. Summary statistics give us an idea of the data ranges and counts. Quick summary statistics describe numeric columns. We use describe to see basic stats on all number columns, like mean, minute, and max. Running the cell now. This summary gives a snapshot of key numeric columns related to customer churn, such as tenure and monthly charges, helping us understand the range and averages in the dataset. Notice how most customers are not senior citizens, mean (0.16), have an average tenure of about 32 months, and monthly charges vary widely, which can influence churn behavior. This quick overview is crucial for spotting trends and preparing deeper analysis to identify factors affecting customer retention. Highs and lows help us spot any surprising numbers or errors. Missing values can cause problems. Let us check for any gaps. #check for missing values. We count missing or null values in each column. Clean data makes analysis easier. Running the cell now. This output shows that our dataset has no missing values across all customer-related columns, which is important for accurate churn analysis. Ensuring complete data helps us confidently explore patterns that influence customer retention without needing to impute or drop records. This step supports the lesson's goal of building reliable insights to reduce churn and improve service. If we find missing values, we will look at cleaning them. Sometimes, data types are wrong. Charges should be a number, not text. #clean total charges column if needed. If total charges is not a number, we try to convert it. We use to underscore numeric with errors set to coerce, so non-numbers become missing. We print how many missing values are now in total charges. Running the cell now. The output shows there are 11 missing values in the total charges in column after attempting a type conversion, revealing data quality issues. This is important because accurate and clean data ensures reliable churn analysis, which helps identify customer pain points and reduce churn rates effectively. Always check that important numbers are really stored as numbers in the data. To keep the data simple, let us drop customers where total charges is missing. #remove rows with missing total charges. We remove rows with missing total charges to avoid errors later. We print the new shape to see how much data remains. Running the cell now. After removing rows with missing total charges, the dataset now contains 7,032 rows and 21 columns, ensuring cleaner data for analysis. This step is crucial because accurate insights on customer churn depend on complete financial information, helping us confidently identify patterns that impact retention. This is a basic cleaning step. There are other ways we could handle missing data in larger projects. Let us talk about which columns help us understand churn. What columns will we use? Customer ID is just an identifier, not useful for analysis. Churn is our main target, yes or no. Features like tenure, contract, internet service, and payment show customer behavior. We will explore which features may explain churn. Running the cell now. Now let us count how many customers have churned and how many have stayed. #see the distribution of churn. We count how many yes and no values are in the churn column. Running the cell now. The output shows the distribution of our target variable, churn, with 5,163 customers not churning and 1,869 customers who did. This imbalance is important to notice as it may influence how we model and interpret churn behavior. Understanding this helps us frame the challenge of predicting which customers are more likely to leave. This helps us see if data is balanced or if one group is much larger. A visual plot is a faster way to see churn counts. This comment describes the purpose of the code block, to visualize the churn distribution. We import the Seaborn library, which is used for making statistical graphics. We import Matplotlib's pyplot module to enable plotting features. We create a count plot showing the number of customers who churned versus those who did not. We add a title to the plot to specify what is being displayed. We display the plot on the screen. Running the cell now. The bar chart shows the count of customers who have churned versus those who have not, highlighting the balance or imbalance in our target variable. Noticing the proportion here is key, as it sets the stage for understanding how representative our data is and how challenging the prediction task might be. This helps us confirm that churn is a crucial column to focus on in our analysis. Visual patterns often reveal more than simple numbers. We will now check if how long someone stays predicts churn. Tenure is how many months the customer has been with the company. Add a comment describing that we are examining tenure in relation to churn. Create a stacked histogram of customer tenure, separated by churn status using different colors. Set the title of the plot at customer tenure versus churn. Label the x-axis as months with company to represent tenure duration. Label the y-axis as a number of customers to show count of individuals. Display the plot on the screen. Running the cell now. This stacked histogram shows the distribution of customer tenure separated by churn status. Notice that customers who churn, yes, tend to have shorter tenures, while those who stay, no, have longer tenures, indicating tenure may be a strong predictor of churn. This visualization helps us understand how customer behavior relates to our target variable. Can you guess where churn happens most? Try to notice the pattern. Does the type of contract affect churn? We will compare churn for month-to-month, 1 year, and 2-year contracts. This comment indicates that we are comparing contract types and churn. We create a count plot showing the distribution of contract types, with bars colored by churn status. We add a title to the plot to describe that it shows churn by contract type. We label the y-axis as a count to indicate what the bar heights represent. We display the plot so it becomes visible to the user. Running the cell now. This bar chart compares the number of customers who churned versus those who stayed, grouped by contract type. Notice how churn rates differ across contract categories, with month-to-month contracts showing higher churn counts, which suggests contract type could be an important factor in predicting churn. This visualization helps us explore which features are linked to customer attrition, guiding our analysis focus. Long contracts often help reduce churn. Month-to-month may show higher churn. Let us see if what customers spend relates to their chance of leaving. We add a comment describing that we will explore total charges by churn using a box plot. We create a box plot to compare the total charges between customers who churned and those who did not. We set the title of the plot to total charges versus churn to explain what the plot shows. We display the plot on the screen using plt.show. Running the cell now. This box plot compares the distribution of total charges for customers who churned versus those who stayed. Notice if the median total charges differ significantly between the yes and no groups, indicating a potential relationship between spending and churn. This helps us identify if total charges might be a key feature influencing customer churn. Box plots show the middle and spread of the data. Outliers may reveal something unusual. Next, we will ask if internet service type affects churn. Comment describing the plot purpose, to analyze internet service and churn. Create a count plot showing the number of customers for each internet service type, separated by churn status. Set the plot title as churn by internet service type to describe the visualization. Label the y-axis as a count to indicate the number of customers. Display the plot on the screen. Running the cell now. This plot compares churn rates across different internet service types, showing how many customers stayed or left for each category. Notice that the distribution of churn varies by service. Some internet types have higher counts of churned customers, indicating a potential link between service type and churn behavior. This helps us identify which features might influence customer retention for deeper analysis. Try to spot which group is riskier for churn. Correlations show how strongly numeric features relate. A heat map makes it easy to spot any strong, positive or negative, relationships. This is a comment explaining that we will create a correlation heat map for numeric features. Here, we list the numeric columns we want to analyze for correlation. We compute the correlation matrix for the selected numeric columns to see how they relate to each other. We use Seaborn's heat map function to visually display the correlation matrix with annotation. We set the title for the heat map to describe what it shows. We display the heat map plot. Running the cell now. This heat map shows the correlations between key numeric features, tenure, monthly charges, and total charges. Notice the strong positive correlation between monthly charges and total charges, which makes sense since total charges accumulate over time. Understanding these relationships helps us decide which features might be important in explaining customer churn. High absolute values mean two numbers change together. Low values mean they are separate. Time to try some hands-on exploration. Mini project, explore reasons for churn. Which feature, e.g. contract, tenure, service type, shows the biggest churn gap? Can you use simple plots for monthly charges by churn? Try grouping by another feature and checking churn rates. Use describe, value_counts, or plots you learned today. Share your findings with us in the comments. Running the cell now. For example, let us group data by payment method and see churn rates. We are explaining what the code does, calculating churn rate by payment method. Group the data by its payment method and compute the normalized counts of the churner values, yes, no, within each group. Print the resulting data frame showing churn rates by payment method with yes and no as separate columns. Running the cell now. This output shows the churn rate split by different payment methods, revealing that customers using electronic checks have a much higher churn rate, around 45%, compared to other payment types, which hover around 15 to 17%. Notice how this simple group B with value_counts, normalize equals true, helps identify payment method as a key feature influencing churn, exactly the kind of insight this lesson wants you to uncover using grouping and plotting techniques. Patterns like this can help companies know which payment types might be linked to higher churn. Let us check if customers who churn have higher monthly charges. This comment describes the plot we are about to create. We create a bar plot showing the average monthly charges for customers who have churned versus those who have not. We add a title to the plot to explain what the chart represents. We display the plot to visualize the data. Running the cell now. This bar plot reveals that customers who churn tend to have higher average monthly charges compared to those who stay, highlighting a potential cost-related reason for churn. Notice the clear difference in the height of the bars for each churn category, which suggests monthly charges is an important feature to consider when predicting churn. This visualization effectively supports the lesson's goal of using simple plots to identify features with significant churn gaps. Average values can point to whether leaving is linked to price sensitivity. Saving clean data makes future analysis or modeling easier. We add a comment to explain that the following code saves clean data. We save the clean data frame to a CSV file named telco_clean.csv without including row indices. We print a confirmation message that the clean data has been saved successfully. Running the cell now. This output confirms that the clean dataset has been successfully saved as telco_clean.csv for future analysis. This step ensures you can easily reload and explore features related to churn, like contract type and monthly charges, without repeating data cleaning. It sets the stage for testing which variables show the biggest differences in churn rates using the plots and groupings practiced earlier. Try loading your cleaned file in a new notebook as practice. Let us review everything you learned today. What did we learn? How to see, clean, and understand a real churn dataset. Checked for missing values and fixed numeric types. Visualized churn using plots and grouped comparisons. Found which features relate most to customer loss. This is the foundation for churn prediction with machine learning. Like and subscribe if this walkthrough helped you learn. Running the cell now. Thanks for watching. Keep practicing and you are on your way to becoming a data pro.